Hey, it's Dr. J. Today I'm combining 4.4 and 4.5, adding and subtracting fractions. Let's do a combo lesson on the two sections. The first thing I want to say before I actually do any problems is that to add or subtract fractions, there's one main rule. The denominators must be the same. Okay, they must have the same denominator. So we'll start with adding. Suppose you have A over C plus B over C. When you add them, you add the numerators, and you do not add the denominator. This is what's called a common denominator. Okay, so let's keep that in mind as we're doing the problems today. Add the numerators, keep the denominator the same. Okay, so the denominators must be the same, and we add, in this case, I'll do subtracting in a minute, only the numerators. So I'll give you an example. 1/5 plus 2/5 is 1 plus 2/5, which is 3/5. All right. Typically, this step here is just done mentally. I mean, unless it's a really complicated fraction with lots of different, symbols and negative signs and things like that, you might want to show that step. But for the most part, you would go 1/5 plus 2/5, and you would just jump right to here and say that the answer is 3/5. Okay. We like to reduce this if it's possible. 3/5 cannot be reduced or simplified. So add and simplify the result. So we got 5/8 plus 1/8. So that would be 6/8. Again, it's very important that you don't accidentally add the 8s. I guess I could draw pictures of little pizza wheels and things again, but I think we've grown beyond that at this point. 5/8, you have a pizza 5 out of 8 slices, and 1/8 is 1 out of 8, and when you add them, you still have 8s. Yeah, you're dividing by 8. Now, we want to reduce this if possible. So 6/8 is, let's just do a little mental math here. That's 3 times 2, or if you prefer 2 times 3, I don't really care. And then 8 is 4 times 2. We got a matching pair, so I can stop now. If I didn't get a matching pair, I would keep factoring, and so the result is 3/4. Oftentimes, students will just jump from 6/8 right to 3/4, especially if you have a good understanding of how fractions work. Subtracting works very much the same way. So subtraction is the same idea. If you have A over C minus B over C, that would be A minus B and then over C. I wrote it backwards. So you have 4/11 minus 3/11. That would be 1/11. And again, as we go through the lessons, I'll probably be jumping right to here. This is really just the mental step that you're thinking about. 4 minus 3, 4 minus 3, and then all over 11. 1 over 11 does not simplify. All right, so don't try to cancel some ones or anything like that. It just doesn't work like that. We might have negative numbers. That could happen. Four fifths minus 7/5. Yeah. So that would be 4 minus 7 over 5. 4 minus 7 is negative 3. So that would be negative 3/5. Or you can write it like this with the negative out in front. I know I've said this before, and I'll probably say it again. You can put the negative on top. You can put the negative out in front. Or if you really want to be interesting or different, you could put the negative down in the denominator. I hardly ever do that unless I'm really trying to be weird. Okay. All right, so that's the basic idea of adding and subtracting fractions. Next, we're going to have to conquer the concept of a common denominator. If the denominators are not the same, then we must find the LCM, least common multiple, so we're going to find the least common multiple of the denominators. This is called LCD, the least common denominator. It's the same process that I demonstrated earlier in the semester with least common multiple, but when we apply this to the denominator, we call it the least common denominator. So we've got 1/12 plus 5/6. So we want the LCM of 12 and 6. Yeah, also known as LCD. Because they're in the bottom, it changes to LCD. But it really means the same thing as LCM. Okay. Now, you might already know it, right? The answer is 12. Yeah, the LCD is 12. But just in case you don't know it, this is how you find it, all right? So what you do is, so sometimes you'll just do this with mental math. And oftentimes with a problem like this, I'll just do it mentally. Right, 12 is the smallest number. You can just kind of talk your way through it. 12 is the smallest number that's divisible by both 12 and 6. Yeah. But just in case you don't know it, And when I say know it, I mean like as soon as you look at the problem. If it doesn't pop in your head immediately, there's a process, okay? The process is you take the two denominators and you stack them on top of each other. Yeah, just like that. And this is just scratch work, really. This is just kind of a little scratch work over here. I'll come back to here in a second when I get to the problem. And then I factor 12. 12 is 2 times 2 times 3. You do want to use prime numbers here. Then you factor 6. 2 times 3. Okay? And I know I've done this before. I'll probably do several of these today. And now you want to make these the same, right? So really, you just look at them and you say, well, look, they're already very close. Look, they both have a 3. They both have a 2. All right, so you just have to give it whatever it's missing, and you want to put it on both sides, and you can give it any number that it doesn't have. So the 12 has a pair of 2s, but the 6 only has 1 2. So we're going to give it another 2. Okay. And that's it. Once they're the same, that's called your LCD or LCM. Yeah. I don't care which one you actually use. This one should be equal to 12, check. And this one should also be equal to 12. That you should probably do them both to make sure that they're the same. Yeah, that's the whole idea of being the same denominator. That's the LCD. All right, so we know that the LCD is 12. So now we're going to go like this. Some of you are going, come on, Dr. J, really? And I'm saying, yeah, really, you know. They get worse. You want to multiply by a special form of 1. That's what we call a special one, or a special form of 1. It's always this number here. Whatever we multiplied by over here when we were doing our LCD, that's what we're going to multiply by here. So 2 and 2. It has to be the same number in the numerator and the denominator. So you have 1/12 plus 10/12. So the final answer is 11/12. Now, that one was pretty easy. I like to demonstrate the process on a very easy problem because they're not always going to be that easy. All right, so let's go ahead and do it. Do you know what the LCD is? If you're good at it, you got a good mind for numbers, you know it's 30. Right? You already know it's 30. I'm going to put a question mark because some people think it's 60. Yeah, some people think it's 60 because 6 times 10 is 60. 6 times 10 is a common denominator. It's just not the least common denominator. We want the smallest common denominator, which will be 30. Well, let me show you how you get that. You stack these guys up. You factor them out. And then you say, what do they need? You really have to do an assessment. What do they need so that they can be the same? Well, they don't need any 2s because they both have 1 2, so that's already the same. The 10 is missing a 3, so we'll go ahead and put a 3 on both sides. Make sure you put it on both sides because it's going to help you when you get over to here. All right. And then for the 6 is missing the 5. And now if you multiply these out, this comes out to be 30. By the way, notice they're all 30. All of them are 30. You don't really have to do them all. 5 times 6, that's 30. 3 times 10, that's also 30. 2 times 3 times 5, that's still 30. And 2 times 5 times 3 is still 30. So, I mean, I guess if one of these does not come out to be 30, then you know you did something wrong. I mean, so it's not a bad idea, but it's not really a requirement. And then look over here. This is going to tell you what your special forms of 1 are going to be. Your special forms of 1 come from over here. Yeah. I'm being really safe. I'm using dots and parentheses to be very, very clear what's happening. Sometimes I just will omit the dot because I don't think it's necessary. But if I really want to emphasize what I'm doing. All right, look at the 6. So that tells me my special form of 1 was 5. This tells you what you're going to use. And then over here, your special form of 1 for the 10 will be 3 over 3. So now you have 5 30ths plus 9 30ths. That's equal to 14 30ths. And then I want you to reduce that if possible. 14 is 2 times 7. 30 is 2 times 15. I guess I could keep going on the 15, but I'm not going to get another match pair, so you can stop now and just kill the 2's. And so your answer is 7/15. I guess I really should have put it down here, but that's okay. You can handle a side step once, you know. I wouldn't do several of these side steps. It starts to get really messy. So remember, work down and then occasionally move over, but you can only move over one time. You know, that's the general principle of arithmetic, being neat with your arithmetic, as opposed to being all upside down and crooked and things like that. Okay. We'll do some more. Sure you do. Let's do some subtraction. Subtraction is the same idea. Okay, so what's the LCD? One thing I want to mention is how the word least sometimes screws with your mind. Notice that these numbers are both divisible by 3. Yeah, they are. That 3 goes into 21 and 3 goes into 9. And 3 is the smallest number. 3 is the smallest number that goes into both of them. So sometimes when I say least, your brain goes small, right? Because least sounds like small. It's never small, all right? The least common denominator is always at least as big as these numbers here, so it has to be at least 21. It could never be 3, right? Funny thing is about the language is 3 is actually called the greatest. How do you like that, right? Even though it's a small number like 3, we call it the greatest. Yeah, it's the greatest common factor is 3. I'm not talking about greatest common factors today. I'm talking about least common multiples, or in particular, least common denominators. Why am I talking still? I'm not doing it because I actually don't know the answer. This is one of the ones where your guess is as good as mine. I don't know. I really don't know what it is until I actually do it. So let's go ahead and do it. Sometimes you don't know until you know. You know? So let's factor these. 9 is 3 times 3. 21 is 3 times 7. All right. So it looks like this one needs a 7, right? Because they both should have one 7. Now 21, it does have a 3, but it doesn't have 2 3s, right? To be the least common, you have to have the same number of factors. This has 2 3s, this only has 1 3. That's not common. Yeah, they don't have the same number of factors, so we're going to give this one another 3, and there you go. And now I feel silly because I kind of already knew it. It was 63, but I didn't want to proclaim it. I didn't want to go, it's 63, because it might not have been 63. It might have been something else, right? So it's better to work it out. I mean, you can make a guess, but never trust your guess. You know, make a guess, maybe write down what you think it is, but then go through the process, and if you get what you thought you were going to get, I got 63. Yeah. I definitely didn't get 3. Right? The answer is definitely not 3. It's also not 100 and whatever, 189 or whatever you might get if you multiplied these. Avoid actually timesing or multiplying the denominators together. That's a terrible, terrible way to do it. All right, so what are we looking for? We're looking for the LCD to be 63. So we're going to multiply special form of 1. That'll be 3 on numerator and denominator. And then for 2/9, we're going to use a 7, 7, and 7. So I've got 30 over 63 minus 14 over 63. And so that gives me 16 over 63. I should try to reduce this. So that would be 2 times 2 times 2 times 2. That's 16. 63 is 3 times 3 times 7. They have no common factors. So that means we're done. If there's no common factors, that means the answer is already reduced. But I at least gave it a try. I was hoping to get maybe one matching pair. But one clue is if the numerators, if one of them's even and the other one's odd, it's highly unlikely, but it's not impossible. It's not impossible. All right. For example, if it was 6 over 63, yeah, that's an even and an odd. That would have been reducible, but not 16. Okay. Example 8. So what's the LCD this time? It's 20. Yeah, can you see that? It's 20. So in the last example, I said avoid multiplying these. Well, I mean, unless it's the only way. All right. In this case, the only way is to multiply them to get 20. That's because these are called relatively prime. 5 is just 5. It's already prime. Yeah. And 4 is 2 times 2. So these are also primes. 5 is already prime. Okay. And they have nothing in common. If they do not share or do not have any common factors, this is called relatively prime. Relatively prime. It doesn't mean that they're actually prime. For example, 4 is not actually a prime number. 2 and 2 are when you factor them out. So if you factor them out and they're either already prime or they don't have any common factors, then we call that relatively prime. And that means that the LCD is just going to be the product of the two denominators. So you don't have to worry about doing the whole process. 5 and 4, those are relatively prime. So we're just going to multiply this one by 4, multiply this one by 5, and that's the only case, the only time that you actually multiply them by each other is if they're both prime or if they're both relatively prime. So you get 4/20 minus 15/20, which is negative 11/20. Right? 4 minus 15 is negative 11. Let's do another one of these. Negative 3/8 minus 4/9. So what's the LCD? All right, well, I don't know. Let's see. 8. 8 is 2 times 2 times 2. 9 is 3 times 3 times 3. Look at them. They do not have any common factors. They have nothing in common. And so that means the LCD is 72. Now, you don't have to play the little game of trying to make them the same. The only way to make relatively prime numbers the same is to multiply them by each other, and then they become the same. So I got negative 3/8. And then I got negative 4/9. All right, I'm kind of spacing them out to give myself some room. This one we're going to multiply by 9. And this one we're going to multiply by 8. I'm using dots instead of parentheses. So now you have negative 27/70. 3 times 9 is 27, right? Yeah, just double check it. And then 4 times 8 is 32/70. Remember, these are both negative. So it's like a credit card. Yeah, you're just going deeper into the negatives. So now you have negative 59/70. I don't think that's reducible. 59 is prime. So I think it's prime. I don't know any number that goes into 59. Okay. So there you go. Sometimes you can't avoid it. The only way is just to multiply the denominators together. If you have a problem with parentheses or multiple negative signs, before you start messing around with the LCD, ultimately we're going to do the LCD in a second here. But just kind of put that on hold for a second, and then let's worry about simplifying the parentheses a little bit. That'll save us some steps here. So we have minus the opposite of negative 7/25, so that becomes plus. Okay, and I don't recommend doing it right here and trying to change one of these signs into a plus sign. Typically, that doesn't work out very well. You might get away with it, but it's not worth the savings that you think you might get. It's better just to write another line The negative, subtracting a negative is the same as adding a positive. Oftentimes I'll get students that will accidentally change this sign. Oh God, please don't do that. All right, save yourself the suffering. All right, so let's do our factoring, 25 and 15. These are definitely not relatively prime because they definitely have a 5 in common. So you don't want to be multiplying them together if they're not relatively prime. Right? If they share a factor, then you want to do it the long way. This is another one where I'm not actually sure what the answer is going to be. So, I mean, this question mark is genuine. I really don't know. I think I know. I've got a good idea. I think it's 150. But I don't know. It might be 75 or it might be something else. I don't know. Now that I just said it, I think it's 75. But my first guess was 150. I don't know. Let's see. All right. So it looks like this one needs a 3. Yeah, so now this one's happy because it has a 3 that the other number has. But now this number's not happy because it only has 1 5. And the other number has 2 5s. Yeah, so they're not happy unless there's, equity, right? They want the same stuff. So, okay, I'll give this one a 5. And I'll give you a 5. And then I like to look at them and go, are you happy now? Yeah. Did you get what you wanted? And they go, yeah, we got what we wanted. Look, I'm 75. I'm also 75. I'm also 75. I'm also 75. Is everybody 75? All right, good. You're all happy? That's your least common denominator is 75. All right. You want to make them happy at the least expense, so you don't want to over flood the gates, right? You want to give them just the minimal amount to make them happy. Right? So you're cheap, right? Or you're economical. All right, I like to keep notes of what I did over here because it reminds me of what I'm doing over here. So when you look at the 25, well, what did I need? I needed a 3, top and bottom. You can either use parentheses or you can use dots or you can use both. It's up to you. You can half and half parentheses, half dots is fine too. Look over here at the 15. What did you need? You needed a 5. Most important thing is to do it on the top and the bottom. You got to have balance. Right? You got to balance the fraction. So now you've got negative 70 over 75 plus 21 over 75. All right, a negative 70 and a positive 21. You're going to subtract, so this is mental math here. You're going to subtract, you're going to get 49, but you're going to have the sign of the larger. Which other one had the larger absolute value? So the absolute value of 70 is bigger than the absolute value of 21. So we're going to give it the sign of whichever one had the larger absolute value, which was 70. Remember, the bottom is 75. That's it. It's done. The denominator is done. So there's your answer. This is also irreducible. Negative 49 over 75. I guess we'll just keep rolling. Yeah. Not a lot of variety in this section. Not until we get to the some word problems or some order of operations or something like that. The first dozen examples or so are pretty standard. Just making sure you run through the paces and get your mind in the fractional mode. All right, negative 7/15 and 8/9. So what's the LCD? I don't know. Let's see. I think I have a guess. I think it's 45. That's my guess. Make a guess. I mean, you might be guessing right all the time, and that kind of gives you a little bit of a, anxiety relief, because you kind of know that whatever your instinct tells you is probably right. But again, I mean, I've been doing this for a long time, and if you only guess and you don't have a backup plan, you'll never know if you're, just shooting in the dark. You don't even know if you're going to hit it, right? You don't know whether or not you even have the right answer or not. I guess you'll find out when you submit and find out if you did it correctly or not. I feel like we've done one very similar to this. This one needs a 5. We haven't done this exact one. We've done one very similar to this. And this one wants an extra 3. And now they're both happy. So the LCD is 45. So the 9, I multiplied it by 5. And the 15, I multiplied it by 3. So now I've got negative 21 45ths plus 40 45ths. So go, again, mental math. 40 minus 21 is 19. And then now decide, is it positive or negative? 40 is larger than negative 21, so it's going to be positive. Yeah, because this has the larger absolute value. I just put larger in quotes, you know what I mean. I mean the one that's the farthest away from 0. Would you rather be 40 away from 0 or 21 away from 0? Which one is further away or farther away? Sometimes we do this and one of the numbers is not a fraction. Something like this. So if one of the numbers is not a fraction, well, make it a fraction. So there's an invisible 1 here. Okay. Now, there is a rule with LCDs involving 1. All right. It's very simple. If one of the fractions has a denominator of 1, then automatically, by default, the other fraction is the LCD, the other denominator. So the LCD is automatically 3. You don't need to do any calculation. That's a free LCD. Yeah? That only happens if one of the denominators is 1. Right? And then automatically the other one wins. Yeah? So that's the least. Right? Isn't that funny? The bigger number is what we call the least. Right? The key is the letter C here. C stands for common. So it is the least common. Okay, so in order to make these the same, we're going to multiply by 3. Top and bottom, that's your free LCD. Make sure you do top and bottom. So now you have 1/3 minus 6/3. So the answer is negative 5/3. Okay, that'll do it for the basic problems. Next, we're going to do 2 things: ordered operations and word problems. op for operations. I don't have enough room to write the entire thing. All right. Now, a couple things I want to mention before I do the problem. Order of operations in the first 3 or 4 chapters of this book and of this first month or so of the semester, month and a half maybe, I'm constantly reminding you order of operations, order of operations, order of. Eventually, I can't continue to do that. I mean, this is math. Okay, so if you're in a math class, you have to follow the order of operations. It's just sort of like the ground rules of math in general. So, I mean, I'm getting to the point where, I'm going to stop saying use the order of operations. I'm just going to say solve or evaluate or calculate or compute or something like that, and you know that order of operations is implied. And then another thing is word problems. Word problems are going to occur in every chapter, right? And so we often call them application problems, or what have now been referred to as apps. So you're going to learn your apps, right? So eventually, I just want it to be clear that I'm not going to have to tell you to use the order of operations, and you're going to expect that there's going to be some apps or some applications in everything that we learn, okay? Otherwise, what's the point, just to learn how to, deal with numbers without actually having a purpose for doing them, okay? So we might as well do some. Let's start with the order of operations. Okay, so this is grouping symbols, also known as parentheses. So first we group, then we do exponents. There are no exponents in this section, so we can kind of skip that. Then we multiply or divide, depending on what comes first or last, left to right. And then finally we do our sums or adding or subtracting. All right, so there's the new order of operations. It's always been this order. It's the sort of spiffied up version of it. All right. Now, in order to do the grouping, this is how you do it. You want to find the LCD. Now, we've done this one before, 9 and 8, so I'll skip all the long talk and get right to it. The LCD is 72 in this case. All right, 72. And then you want to do this. You want to treat the top and the bottom separately. So you're going to multiply 72 across the denominator, and you're going to multiply 72 across the numerator. And you're essentially treating these as 2 separate problems. That's what grouping is. There are 2 groups. There's the group in the numerator and the group in the denominator. Okay? You have to do both. All right? You can't just go, oh, I don't really want to do both. I just want to do one of them. Because sometimes the bottom might look easy. You're like, I don't really want to do it to the bottom. It doesn't matter. Right? You don't really have a choice. You have to multiply the top and the bottom every single time. All right. So notice that there's a big division bar that goes between these. So make sure you keep them separate. Make sure you know who is on top and who is on bottom. So distribute that 72. That's going to be 2 times 72 minus 5/9 times 72. And then the bottom is going to be 1 times 72 plus 3/8 times 72. All right, let's do the easy stuff first. So let's multiply next. All right, so 2 times 72, that's 144. Now this one, 5/9. Well, 9 goes into 72 8 times. 5 times 8 is 40. Yeah, so that 72 is gone, the 9 is gone, and you're just multiplying 5 times 8. Let's do another one of those. 1 times 72 is 72, plus 8 goes into 72 9 times. 3 times 9 is 27. Okay. There is a longer, more defined way of doing this canceling here. In the early stages, I was encouraging you to take it step by step, but as we move through the material, I'll start to, expect a little more and to sort of, turn up the complexity a little bit so that you can do that quickly. If this is a problem, then the long way is not too much longer. It would be something like this. You'd write 72 as 72 over 1. I'm doing it the long way, just one time. 5 times 9 times 8 over 9 times 1. So I'm breaking up the 72 as 9 times 8. Then I'm crossing off the 9s. Then I'm going 5 times 8, which is 40. And then divided by 1 is still just 40. So usually we omit the 1. So that's the long way in case you need a refresher on how we did it that way. All right, I'm running out of room here, so I'm going to move over. 144 minus 40 is 104. 72 plus 27 is 99, I believe. You could try to break this up, factor it down, but I don't think it factors anymore. Let's give it a try. 104 is 2 times 2 times 2. 2 times 2 times 2 times 13. 104 is 8 times 13. It's one you hardly ever remember, right? 104. 8 times 13. 99 is 3 times 3 times 11. Nope. No common factors. So we're done. 104 over 99. We just got done doing a whole section on mixed numbers. We'll probably come back to mixed numbers in the next lecture, but for now, I'm just going to leave my answers as simplified fractions. Sometimes they're proper, sometimes they're improper, but I'm not going to take the extra time to discuss mixed numbers today. All right, here's a very similar type of problem. Again, we have the grouping symbol here. Yeah, that's our G for grouping symbol. Then our exponents, multiplying, and then subtracting or adding, or sometimes called sums. Technically, subtracting is a type of sum. Yeah, it's summing a negative. We call that subtraction. The summation of a negative is a subtraction. Also called a subtrahend if you're into fancy words like that. Okay, so what's the LCD here? Well, be careful. Sometimes you might think it's 21. Yeah, 7 and 3. Those are prime. They're definitely relatively prime. Prime numbers are automatically relatively prime. So 3 times 7 is 21. You might accidentally do 21. All right. It's not. It's not 21. That's because the 3 actually has a denominator of 1. So you're not finding the LCD of 7 and 3. You're finding the LCD of 7 and 1. That was what I called the free LCD. The free LCD is 7. So now remember, you have to multiply the top and the bottom by 7. And this is where, what you want to do really doesn't matter, because I have to admit, I don't really want to do the bottom. I mean, look, the bottom is already a whole number. Why would I want to go ruin a perfectly good whole number by multiplying it by an LCD, right? And that's because if you only do the top, then you have just multiplied the whole thing by 7. And you can't do that. You can't just take a problem and go, hell, I'm going to multiply it by 7 and see what happens. You can multiply the top by 7 and the bottom by 7 because now you have just multiplied by 1. Remember, we call this the special one, or the special form of 1. So I want to make that very clear. You know, sometimes it seems like, oh, I just want to do whatever's easier, or whatever's quicker, or whatever, something like that. But you have to do what's right. You have to do what's the truth. Whether you want to do it or not really doesn't matter. All right, so now we got 7 times 1. I'm just going to write it out. And then we got 2/7 times 7. And then we got 3/1 times 7. All right, 1 times 7 is 7. 2/7 times 7, that's just 2. Those are already factored out, so you can just cancel them. You're going to get 2. And then 3/1 times 7/1 is just 21. You can omit the 1. There's no need to write the invisible 1 on the bottom. And then finally, 7 minus 2 is 5, and the denominator is 21. And again, it's irreducible, so the result is 5/21, or 5/21. One of the reasons that the old PEMDAS has gone out of fashion is because of problems like this. This is exactly the reason why, and it, you know, I'm saying this, even the book still does call it PEMDAS, only because it's traditional algebra, pre-algebra book, but if you read the chapter, when they explain PEMDAS, they immediately give disclaimers. Kind of like I've done, right? And they immediately say, oh, by the way, P doesn't really stand for P. P stands for G, grouping symbols. And E is the only one that remained E, and so on and so forth. But this is one of the reasons you do not always add and then subtract, right? You always want to do your sum from left to right. So you do not always add and then subtract. You always summation, which means add or subtract. So really the way it was A or S, M or D, depending on what order they appear in the problem. So in this particular problem, you're going to subtract first and then add. You have to go from left to right. All right, what's our LCD? Let's see. So I got 3. 3 is already prime. Don't have to do anything to it. 5. 5 is already prime. Don't have to do anything to it. 10. 10 is 2 times 5. All right, and now you want to make them all happy. We have 3 denominators now. Well, this one definitely wants a 5. These two want 3s. Oh, remember, whatever you put on one side, make sure you put the same thing on the other side. Are they all happy? Some people are not happy. These two are not happy. Yeah, because this one has a 2 and they don't have a 2. So let's give them what they want. Give them a 2. All right. Are you all happy now? You should all be the same now, right? 2 times 5 times 3, that's 30. So there's my LCD. 3 times 5 times 2, that's still 30. Same thing here. 5 times 3 times 2, that's still 30. 2 times 5 times 3, that's still 30. Here's the easiest one. 3 times 10, that's 30. Yeah. all different ways to say 30. Look, 2 times 3 times 5, that's also 30. Yeah, 2 times 3 is 6, and times 5 is 30. And then again, I already did that one. 2 times 5 is 10, 10 times 3 is 30. They should all come out to be 30, otherwise you made a mistake. Okay, so we got a 2/3 minus 1/5 plus 3/10. All right, we're going to multiply the 10. Now, this is my little line here. So I'm going to multiply the 10 by 3, top and bottom. The 5 gets multiplied by 6. Yeah, 2 and 3 is 6. If you have the patience, you can just write 2 and 3 if you really want, but it's going to be 6. And then for the 3, for the denominator of 3, 2 and 5 is 10. So instead of writing 2 and 5, I can just write 10. All right. And now we're going to sum from left to right. So we've got 20/30 minus 6/30 plus 9/30. So let's go from left to right. That's 14/30 plus 9/30, and so the answer is 23/30. Okay, there you go. So I'm going from left to right, doing the far right last. Okay, so division, yeah, exponents, parentheses. So when we go through the order of operations, grouping symbols, parentheses, do that first. Well, there's nothing to do. Yeah, it's already been done, 5/3. So just go to the exponent. That will be 25/9. Yeah, 5 times 5 is 25. 3 times 3 is 9. All right, now we're going to do division and multiplication as they occur from left to right. So we're going to do this one first. Division means reciprocate and multiply. So flip, 63/5, flips, and then multiply. You want to kill 2 birds with 1 stone. These are both multiplications now, which is, again, why the new acronym M stands for both multiplication and division. You don't have to have the D in your acronym because division is multiplication. All right. Now let's do some simplifying now. All right. Because if you start to multiply, you're going to regret it. You're going to get these big numbers. You're going to be like, oh my God, what did I do? I made a big mess, right? So let's factor this out and see if we can give ourselves a little bit of a break here. So 49, 7 times 7, and then 5. 15 is 3 times 5, and then 63 is 7 times 9. I guess I could keep going with the 9 if you want, but notice there are no other matching pairs, so it's futile. It's not really going to produce anything new. So here we go. 25. We got 5 times 5. Technically times 1. Although you really don't need to put that 1 there. 9 is, again, 3 times 3. But since there are no 3s in the numerator, I might as well have just left it as a 9. 105 is 5 times 21. All right. And again, I could have just left this as a 9 because there are no 9s or 3s in the top. I can also leave the 21 as 21 because there are no 3s or 7s in the top. Sorry about that. All right, so let's do a little simplifying. Let's cancel some 7s, some 5s. So we have 7 over 27. And then here, I think all we get is a pair of 5s. That's as good as it gets. So we get 5 over, I don't know, whatever that is, 189. We're not even close yet. We got way more work to go. I just ran out of room, so let's come back up here. Now I need an LCD. I'm doing my sum. I'm at the very last step here. Now notice I already had these guys factored. And then I multiplied them together. But then when I'm going to go do the LCD, I got to factor them out again. So 27. 27 is 3 times 3 times 3. 189. 3 times 3, that's 9. Look down here, 9. And then 21 is 3 times 7. I'm glad I did that. Because I have to tell you, down here, when I looked at these denominators, you know, and I like math, and I was looking at these going, oh my God, these denominators are horrible. But look, they're already almost the same. They're this, all they need is one number to be the same. So just give them what they need, and that's it. Done. So they both have 3 3s and 1 7 now. So the only thing I have to do is multiply by 7. In particular, I only have to multiply the 27. I don't have to change the 189 at all. This is one I never learned in elementary school. Yeah. 27 times 7 is 189. I mean, how many people learned that in elementary school? Not me. I didn't learn that. So finally, our answer is 54 over 189. Oh, it's actually not. We need to reduce if possible. Oh man, this is a math teacher's dream here. Yeah? I know I already shifted over, now I'm stuck over here now. I probably should have stayed over here, but whatever. All right, 54 is 9 times 6. 189 is 9 times 21. Keep going. 6 is 2 times 3. 21 is 7 times 3. Who would have thought? That just blows my mind. That huge expression with all these expressions, parentheses, exponents, multiplication, division, it basically had everything. That was the whole stew. And 2 sevenths. Yeah, it's the whole pot. It's everything. It's an all-you-can-eat buffet. And the answer is 2 sevenths. Nice. I love it when that happens. Not what I expected, but whatever. righty. I don't know how much more of these I can handle, but let's at least do one more. All right. They all basically follow the same steps. It's just there's different variety of arrangements, right? It can be arranged in lots of different orders, but the basic layout's the same. If you see a negative on the outside, just ignore it, but don't forget it. All right. You definitely don't want to put that negative inside. You want to keep it outside and do the inside first. All right. That's the grouping symbols. So grouping symbols mean do whatever inside the parentheses first. Then we'll do our exponent second. Then we'll do our products, multiplications, and then we'll do our sums last. So group, exponentiate, multiply or divide, and then sum, which could include subtraction. This one's one hopefully you already know, right? 2 and 3 are relatively prime. In fact, they are prime. So that means we're just going to multiply them by each other. So this one gets multiplied by 3. This one gets multiplied by 2. So you have 3/6 plus 2/6. Again, I'm ignoring the negative sign. And then I'm adding these up, 5/6. Okay. All right, now I want to make very clear how you say this. This is not negative 5/6. This is 5/6 squared, then negative. So if you want to say it, it's negative and then 5/6 squared. So you want to do 5/6 times 5/6, which is 25/36, and then bring down the negative sign. That's why you don't want to put the negative on the inside, because then you would be squaring a negative and it would come out to be positive and you'd get the wrong answer every time. Okay, now let's do this one. This is the same as 2 over 1. So 2 times 5 is 10. 1 times 6 is 6. Now, normally I would reduce this. Under normal circumstances, I would reduce that. But because I'm trying to find a common denominator, I'm not going to reduce it. I'm just going to leave it. This is 36. This is 6. The LCD is 36. It's not too late for me to say it. If the smaller number goes into the bigger number, so 6 goes into 36, then that means automatically the bigger number is the LCD. Right? So suppose you had 5 and then suppose you had 20. Well, 5 goes into 20, so the LCD would automatically be 20. Yeah. Just to show you that it doesn't have to be 6 and 36. So the LCD is 36, so I'm going to multiply this by 6. So now I've got negative 25 over 36 plus 60 over 36. Add this up, and you're going to get 35 over 36. Make sure the sign is right. So 60 is positive, 25 is negative, so we're going to give it the sign of the positive, the 60. Okay, I guess that's enough of the order of operations. This really never ends, so I know that if I don't, spend another 10 minutes on it now, eventually we'll spend that time eventually. Before I wrap this up, we have 2 more objectives, or I guess one more objective, word problems. Yeah, word problems. Now, I'm kind of going easy on you today. These are not the big story type paragraph long word problems. These are just sort of the one-liner problems. Let's start with translating. What is negative 3/5 less than 1/4? So this is what I call a one-liner. It's a word problem, but it's not a big endeavor. It's mainly about me hammering this home that when you do less than, you have to reverse the order. So this is what it translates into. Negative 3/5 goes inside the parentheses. Less than is subtracting. And you're subtracting a negative. So that's going to be addition. Okay. And then now we're going to find the LCD, which is 20. That's one you could do in your head. 4 times 5 is 20. I think we talked about this before. So I'm going to multiply this one by 5. Multiply this one by 4. And the result is 17/20. So what is negative 3/5 less than 1/4? That is 17/20. Main thing is the order. Make sure you have it in the right order. So that's not much of a word problem. Let's do one where you actually need to know a formula to solve it. What is the average of 1/9 and 5/12? So the formula for average is the sum divided by the number of addends. Yeah. So the number of addends, these things are called addends. An easier way to say it is terms. Yeah. So you add and then you divide by the number of terms. That's the quick way to remember it. Sum means add, addends, number of terms. So there are 2 addends. There are 2 terms in this. So the average, it's usually abbreviated AVE for average, is 1/9 plus 5/12 divided by 2. Now, this looks a lot like a problem we did earlier. It's just I wasn't calling it the average back then, but this is basically the same setup. What's the LCD? The LCD, 9 and 12. Can you see it? If you can't see it, make it. So 9 is 3 times 3. 12 is 3 times 2 times 2. So this one needs an extra 3. And this one needs a pair of 2s. And so the LCD is 36. I'm glad I didn't guess. I was going to guess 72. Yeah, my brain's probably getting tired, so I was going to guess 72. 36 is the least common. So we're going to multiply the numerator by 36 and the denominator by 36. So I'm just going to rewrite it up here so everybody can see it. 5/12 times 36. And I'm going to distribute that. And then I've got 2 times 36. Last time I did this problem, I wrote 2 over 1. And then I told you can omit the 1, so I'm just omitting it now. All right, so I've got 1/9 times 36, and technically that's 36 over 1. And then 5/12 times 36 over 1. Let's just go ahead and get the bottom over with. That's 72. And I'm going to do some quick canceling here because all of these numbers are factorable and they have common factors. 9 goes into 36 4 times. 12 goes into 36 3 times. So I've got 1 times 4 plus 5 times 3 over 72. So the final answer is 19 over 72. It's not reducible, so that is the average. Okay, I guess I'll stop there. There are more word problems. I don't know, the words are escaping me now. There are more word problems, and there's going to be more geometry and some more applications of fractions in the next couple sections. But until next time, this is Dr. Jordan, and I will see you on the internet.